So this is another lecture on computer graphics software and database. So for this week, we will discuss about the computer graphics and how the latest softwares, modern computer softwares incorporate these computer graphics, or how these computer graphics will be utilized for the creation of new applications and new softwares, etc. So here, the computer graphics software is a collection of programs written to make it convenient for a user to operate the computer graphics system. This means actually various programs like in Python, C++, C language, Fortran language are written to make the graphic applications for the software. For example, uh, if you use an AutoCAD system, AutoCAD provides the 3D facilities. So in the backend, the authors or the creator of the software provides uh, the programming in various languages for that particular graphic system which you will use as a 3D system in AutoCAD. Okay, so it indicates programmers to generate image on CRT screen, cathode rays screen to manipulate the images and to accomplish various types of interaction between the user and system. So it is also main function of a graphics software system that it should be user friendly. For example, if you are visualizing an image in AutoCAD system or Autodesk or any other software, so it should be user friendly, or it should be convenient for the user to check the details on the graphic system. Okay. So in addition to the graphics software, there may be additional program for implementing certain specialized function related to CAD CAM. These include design analysis program, finite element analysis, and kinematic. These are basically the examples of graphics-based softwares. For example, finite element analysis software, basically the software which you are using, ETAB and SAP 2000. So these are basically finite element software. Other ANSYS, Abacus are also the example of finite element analysis. And further, the manufacturing and planning phase softwares, for example, Primavera is also the part of graphic software system. So this chapter deals mainly with the graphic software. The graphic software for a particular computer graphic system is very much a function of the type of hardware used in the system. So first of all, it is clearly mentioned here, the graphic supporting capability of a system depends upon the hardware of the system. For example, in general talk, you can say your latest i7 computers support the latest NVIDIA graphics, for example. Okay, so but P3 system does not support the latest graphic system. So the graphic capability of the system is always depends upon the hardware used in the system. Okay, so first of all, you must have to ensure your hardware system is capable uh, to take these graphic system and make it convenient for the users or not. The software must be written specifically for the type of CRT and types of input devices used in the systems. Further, it is mentioned here, the graphic application should be developed according to the visualization screens. For example, if you are using the monitor, if you are using the LEDs, if you are using the LCDs, the graphic should be according to these visualizing devices. Okay. For example, the graphic system for monitor will be different, and for LCDs it will be different, and similarly for LEDs it will be different. The details of software for stroke writing CRT should be different than for a raster scan CRT system. This is actually the basically the scanning system, just like if you are using the inkjet printer. Okay, so for example, the typewriter printer, in which basically the typewriter provides the impression on the paper, and in case of laser printer, the basically laser option will use. So this is this type of line the author is saying in this line. The differences between a storage tube and a refresh tube, this is basically the details of graphic system. It is not mandatory for your course, although these differences in software may be invisible to the user to some extent. They are important consideration in design of, basically this paragraph deals with the design of the graphic applications for any user system. Okay, so this is basically the detailed discussion regarding the computer software company and regarding the IT systems. So you can leave this paragraph for your exam preparation, because this is not a part of our system. Newman and Spaull list 6 ground rules that should be considered in designing graphic software. So if you are designing a graphic software, So these 6 rules must be adopted. Okay, so these are 6 rules. The first one is simplicity. The graphic software should be easy to use. Okay, and the other is consistency. The package should be operate in consistent and predictable way to the user. For example, it should be easy or user friendly for the users. It's the simple meaning of this line is this. Completeness. There should be no inconvenient omissions in the set of graphic functions. Inconvenient omissions mean the graphic should be uh, regular, or mean you can say that there should be no uh, offensive lines and no different types of graphic should be interpreted with another. For example, if you are visualizing the green line on a monitor, so it should be the green. There should be no red line, and another line should be interpreted in your graphic system. So this is basically the example. Actually, for example, the same regular graphic or uniform graphics should be visualized. The another is robustness. The graphic system should be tolerant of minor instances or misuses by the operator. So graphic application for the system should be such like that the user, when the user will use such graphics, then it should automatically incorporate the minor errors produced by the users. Okay, so it should be capable for user mistakes. Okay, to capture the user mistakes automatically and display the actual output or performance within limitations imposed by the system hardware. The performance should be exploited as much as possible by the software. Graphics system should be efficient, speed of response should be fast and consistent. It should the performance of the system should be good enough for the users. For example, the graphic should not be too much high. For example, if your hardware it does not support the latest graphic system and you are using graphic software, for example latest Autodesk software, Revit software, and your computer does not support the latest graphic, so the graphics for that particular system should be designed in such a way so that the system will give the output to the user in a fast way. It should not be the jerky, it should not be the inconvenient for the user. Economy graphic program should not be so large or expensive as to make their user prohibitive. So these programs should not be too much expensive so that buyer cannot buy the program. Okay, or it should be the it should be the medium way range. For example, like 20 to 50,000 range software should be. The software should not be go around the 1 lakh, 2 lakh, and something on. So this is basically the economy. When the softwares, when the mostly using softwares should be at the mid range of money, because everybody cannot buy these softwares if these softwares are too much expensive. Now the software configuration of a graphic system. In this system, actually, you will see in operation of the graphic system by the user, a variety of activities takes place which can be divided into 3 categories. Okay, just a minute. Okay, in operation of graphic system by the user, a variety of activities takes place. When you will use a graphic software system, the following activities may be occur. For example, the number one, interact with the graphic terminal to create and alter images on the screen. For example, by using the graphic software, you can generate another graphic, you can generate another drawings. For example, in AutoCAD system, you will generate another type of graphic system. Thus Autodesk software has its own self graphic system, but on that software you will create another graphic graphic drawing or graphic options. For example, you are creating that 3D drawing in Autodesk Revit, then another graphic is produced in your Autodesk system. And Autodesk is basically the on Autodesk has its own graphic system capability. Number two, construct a model of something physical out of image on the screen. Model are something called application models. You can generate various types of models. So number of models can be utilized in a one graphic software, and this is the capability of the actual graphic. Enter the model into computer memory and secondary storage. or you can save your computerized models. For example, if you are making a model in ETABS, so you can save your 3D models in your computer. Okay. In working with the graphic system, the user performs these various activities in combination rather than sequentially. Basically, these all activities are on the spot. Okay. For example, you have opened the ETAB, you model the building and you save that. Okay. It is not possible that you model the building and shut down your program and you will save on another day. Your data will be lost if you are doing such that. So the user constructs a physical model and inputs it to memory by interactively describing image to the system. This is done without any thought about whether the activity falls into category 1, 2, 3. So these functions are basically the combined functions, combined categories. You do these categories on the spot. The reason for separating these activities in the fashion is that they correspond to the general configuration software package used with the interactive computer program. Basically, the author is saying you cannot separate these categories. If you separate, then the software company should make an extra efficient capacity for the users to solve the problem for these individual categories. So basically, it is basically the combined activities. The meaning of this paragraph is that the graphic software can be divided into three modules according to the conceptual model suggested by Foley and Van Damme. Okay, so Van Damme is basically the very famous IT graphic software engineer. He suggested the three modules of a graphic system. The first one is the graphic package, the application program, the application database. And you already know about how the database will function this graphic system. I have already told you in some previous lectures. The graphic package is basically the new in this system. The application program means the programs which supports graphics system. For example, Autodesk, AutoCAD, ETABS. These programs support another graphic system capability. For example, you create a model, another 3D model, another graphic is generated by using these graphic software. Okay. So this is basically the model of graphic software configuration. The application program is implemented by the user to construct the model of a physical entity whose image is to be viewed on the graphic screen. Basically, you open the ETAB or any other AutoCAD software, and you will generate your own drawing on the software. Application programs are written for particular problem areas. So for the graphics which you generated in your computer are based on the computer programs which are already fed in the graphic software. Problem area in engineering designing would include architecture, construction, mechanical component, electronics, chemical engineering, and aerospace engineering. Problem area other than design would include flight simulators, graphic display or data. So these are basically the graphics sport facilities which are required for the application software and even data. In each case, the application software is developed to deal with the images and convenient which are appropriate for that field. Basically, these are some fields, for example, flight simulator, mathematical analysis. These fields, aerospace, these fields normally required a graphic software system. Okay. So this is the model of graphic software configuration, how you can configure your graphic software. For example, application database, you need the large amount of database, large amount of coding in Python, in Fortran or in C++ languages. Then you use such that database, that programming languages into the application program. Then your application program will be capable. First of all, you will have also you must have to check either your application computer programs support this database or not. Okay, if your computer program support this database system, then your program will introduce new graphic software capability on the basis of this database. Okay, and then after the supporting of the application computer program, the graphic database, then and the graphic package is introduced. For example, uh, in our you have already used AutoCAD 2007. The AutoCAD 2007 does not provide the too much capability of 3D system, but nowadays AutoCAD 2020, 2019 and 2020 will be utilized for high graphic system. So another type of graphic system is incorporated in the AutoCAD system with the help of The database means the coding, the programs, and another graphic package has been introduced. Okay, so design workstations. What should be the graphic design workstation for such manufacturing? The graphic terminal basically, and then the user input devices. Okay, the graphic package is the software support between the user and the graphic terminal. Okay, graphic terminal means LEDs, LCD, etc. It manages the graphical interaction between the user and the system. It also serves as the interface between the user and the application software in general lines. The graphic package consists of input subroutines and output subroutines. Okay, so input subroutines mean input the codes or the programming of that graphic system, and output which you are facing on the screen of monitor, on the screen of your LEDs. So both subroutines mean the basically the codings, the programs which the author have been written in your application software. The input routines accept input command and the data from the user and forward them to the application program. Okay, you have already fed the code in the application software. So when you will use, for example, AutoCAD, when you want to draw a line, then you must have to input the command. So how and why the AutoCAD demands the command to draw the line? Because a system, a program language is also incorporated in the backend system of the AutoCAD. If there is no programming in the AutoCAD, then AutoCAD will not ask you for to enter the command to proceed the drawing. Okay, so this is basically uh, the input subroutine, and it is written the input subroutine inputs command and data from the user and forward them to the application program, and your application computer program show the results of that input. The output subroutines control the display terminal or output devices and converts the application model into two-dimensional or three-dimensional graphics software. This is basically the output subroutines mean the data which you are facing in the front of screens. Okay, so the graphic package is a software support the user and the graphics terminal. It manages the. This is the same line. The third module in the graphic software, this means basically the graphic software is the database. The database is the main part for any graphic system, for any application system. If you don't have the database, you cannot develop the graphic system, or you cannot input your graphic capability into the supporting application software. Okay, so first of all, you must have to develop the database. Database means the backend data, the backend storage, the backend features or functions that defines the direction of your graphic software, that how graphic software will work. Okay, the database contains so what type of database can be included in your graphic software? So the first one is mathematical operations, numerical and logical definitions of application models such as electronic circuits, mechanical components, automobile bodies, and so forth. It also includes alphanumeric information associated with the model such as bills of material, mass, properties, and other data. So all these data for a graphic software will be utilized as a database. Okay, for example, if you are using the E tab, when you will define the materials, so when you will click on the drop down menu, the drop down menu show various type of concrete materials which are generally used in the field. Okay, so how the software is showing the various type of materials, the various type of sections and various type of functions to the user, because the author has a large amount of database and they have put it the database in the software. Now the software is in the phase so that so that the software will ask you to enter the following function. Okay, so this is the way. The content of the database can be readily displayed on the CRT screen or plotted out in hard copy form section. Functions of a graphic system. So these are basically the function of graphic system. So in this system, you will check basically to fulfill Its role in the software configuration, the graphic package must perform a variety of different functions. Basically, it is related with the graphic configuration. When you are developing a graphic system, then these are basically the graphic function which we will use if you are developing a graphic system. These functions can be grouped into the function set. Each set accomplishes certain kind of interaction between the user and the system. Some of the common function set are generation of graphic elements, transformations, display control and windowing function, segmenting functions, user input functions. So these are basically the functions which you will use for any graphic system. Okay. So first of all, transformations. Many of editing features involve transformations of a graphic elements or cell composed of element or even the entire model. In this section, we discuss the mathematics of this transformation. Two-dimensional transformation are considered first to illustrate the concept. This is with the three dimension. Okay, so here it is mentioned how your mathematical calculations will be utilized to show the final result in the form of 3D or in the form of final drawing. Okay, so for example, if I want to give an example, if you want to analyze a beam in SAP 2000, so when you will enter the output input, for example, the loads and the sports condition, then within the seconds, the SAP 2000 will show the results of bending moment diagram, shear force, and etc. So what is the thing you can imagine that transform the input result into the output within the seconds? If you for example, if you are doing such analysis in your academics, for example, the teacher solve the question on the board and it is very lengthy procedure. So where what about the calculation the teacher have shown in your whiteboard? What about the calculation in software? Where are these calculations that teacher solve on the whiteboard in software where you can see? So all the calculations which the teacher shows on your board are basically incorporated in the software with the help of this matrices function. Okay, matrices function normally you utilized in your SAP and data program. So these system basically transform your numerical models or numerical working in your final results. But software doesn't show these calculations because the user basically demands the results only. And the user does not demand the complete calculations. So this is basically the transformation, how these calculations are transformed into the results directly in the software. So here it is mentioned elements or cell composed of elements or even the entire model. So entire model can be analyzed with the transformation of these calculations. So here it is also the detail, too much detail about the transformation, two-dimensional transformation, and now then there is three-dimensional rotation. So this is another example how to transform these lines. Uh, if your computer show these lines, so this is actually the numerical working behind these lines. So software will incorporate this, and then there is a three-dimensional transformation. Okay, the concatenation, this is basically the previous single transformation can be combined as a sequence of transformation when you are basically your software support 2D and 3D. So if the software support both 2D and 3D, the combined function can be done. So this is called catenation function. Okay, and this is the example. So this is the last heading of this lecture, solid modeling and wireframe modeling. It is very important for a cost point of view. In this case, wireframe and solid models give visual rendering of 3D objects for computer-aided design and manufacturing program. Basically, the 3D objects which you will face in the screen of your system, on the screen of your system, in CAD CAM, in AutoCAD, or in other graphic softwares, for example, Autodesk. The main difference between the function of this heading is actually you should be familiar with solid modeling and wireframe modeling and the difference between both. The main difference between the wireframe and solid models concern the amount of surface details. So how much the surface detail, how much the details of 3D system you required. So basically it all depends on the solid modeling and wireframe modeling. Okay. Actually, the solid modeling is provides the great details. Basically, it's all basically the function of rendering. If you have worked out with architects or any other consultancy company, then you have then you have already listened the word about the rendering. The 3D drawing renders. The renders are basically use the rendering function in various graphic system to model the 3D final drawing. Basically, the interior designers, the landscape designer, the exterior designers, which design the buildings, interior and exteriors, are basically they are used. They are used basically. The rendering software, 3D rendering software, 2D rendering software, and these softwares will incorporate the all 3D functions or all 3D graphic capabilities into the output result. So the main difference between wireframe and solid models concern the amount of surface details. So what is wireframe? In wireframe, just the outline of 3D objects with information about the edges, nodes, and vertices. Transparent, no coloring or solid fill, no indication of material thickness. Files are light in size and regenerate easily on the screen. So this is basically the touch or access to the 3D system. This is not a fully 3D diagram, fully 3D models. You can't develop the fully 3D models with the help of wireframe model. So this is basically the example of wireframe modeling. If your software supports the wireframe modeling, then your software will done the 3D modeling in such like that. So what about the solid modeling? This is basically the solid modeling, the complete 3D generation. More details and realistic representation of an object. This is solid model. Node transparent include information about edges, node and vertices in addition to coloring. Solid fill and surface featuring. Files are larger than wireframe files and generate less easily. Basically, the file size will be greater than this wireframe modeling in case of solid modeling. So this is all about our today's lecture regarding the graphic capabilities, graphic software applications, and solid and wireframe modeling. So this is basically the main concern of this lecture. Further, your ETABs, the integrated computer softwares, for example, ETAB and SAP 2000, generally support the both wireframe and solid rendering. Actually, when you will run the 3D model, you have the option in your AutoCAD or SAP 2000. You can generate either the wireframe 3D system or you can solid. But the Abacus or ANSYS, basically the finite element software generally support this solid modeling. Okay, so solid modeling is actually required for the user. For example, if an architect produce a drawing and show to the client, so your client would be attractive for this drawing, not for this drawing. Okay, so your latest computer software must support this solid modeling facility or capability. To support this capability, this facility, your software should be heavy enough to support the capabilities. And it is very obvious the software companies will sell out the software having the capability of solid modeling at a very expensive rate. So that's the difference actually. So in now latest software system or in modern world today, basically all type of softwares uh, have incorporated with solid modeling feature. So this is the basically main. So here, these are basically example. You can leave this example for your course point of view. Okay, and you can just know the concatenation details in just a brief point of view. And three-dimensional transformation, two-dimensional transformation, just concept is required. Okay, so this is the lecture for your coming week. You can read out and we will discuss the details or any other problem and issues in our upcoming lecture on Monday. So up till now, this is um further you can check about the CRT screens on Google. You can check the various basically CRT screens and about this paragraph. For example, I'm going to show you again. ICG, for example, and the user constructor physical model. Just a minute. Where it's, yeah, here it is mentioned. The detail of software stroke writing CRT would be different than a for raster scan CRT. So such type of information you can be you can utilize, or you can generally check, or you can check the details in Wikipedia or Google. So this is basically not the main part of your course. Basically, the main part of your course is to have to familiar with the graphics software capabilities, solid rendering, wireframe rendering, and this is basically the some details about the IT or IT systems, or basically for computer programmers and for such like that. So this is all about our lecture. If you have any confusion, then you can also contact me. Up till now, thank you very much.